welcome to EC Electronics. This is a part 4 of NESAC solution. So I have been doing the part 1, part 2 and part 3. I have uploaded the solutions of NESAC. So this is a part 4. In this video, I have included a lot of questions. So I've been receiving requests to do more questions in each video. So I have tried to include a lot of questions in this video. So please watch this video till the end. If you are preparing for DMRC Junior Engineer or ISRO Technical Assistant, the LPSC examination is going to happen very soon. So if you are preparing for any of this post, please do watch this video till the end. And also for any other post of electronics, any competitive examinations of electronics, doing such question papers, the solutions of these question papers are really helpful. Okay, so please do watch this video till the end. Let us move on to the first question. Choose the most accurate voltmeter. Okay, so here certain voltages and current values of the voltmeters are being given. Now, how to choose a voltmeter which is very good or which is very accurate? The condition for the proper working of a voltmeter, or the voltmeter is designed in such a way that it should have an infinite resistance so that no current is actually flowing through it. Okay, so that is actually the ideal case while designing a voltmeter. And here we know that all instruments are having some errors. There will be some problems or errors will be present in the any components when working in real, right? So we have to choose the voltmeter with minimum current. Since the current value has to be 0, we can choose a voltmeter with minimum current. Since all the voltages are equal to 100 volt, all the voltage readings are same. The current value is 10 milliampere, 0.1 ampere, 0.2 ampere and 20 milliampere. So here 10 milliampere is a minimum current, right? So we have to choose the voltmeter which is giving voltage. Anyway, all voltages are same and with minimum current. So the condition is that it should have a infinite resistance. So while choosing the voltmeter, you have to choose a voltmeter with which is having minimum current. Okay, so ideally, the current value should be equal to 0 with infinite resistance. So that is the case. And the correct answer here is option A is the correct answer. Next, move on to the next question. If 3 amps flows through a 10 ohm resistor, sorry, a 1 ohm resistor, if 3 amps flows through a 1 ohm resistor, what is the voltage drop? So this is a very simple question. V is equal to IR is the relationship. Now this type of questions is actually meant to confuse us. Sometimes we may think some other way and we'll write a wrong answer. This is simply application of Ohm's law here. So if R is the value of resistance, I is the current flowing through it, then what is the voltage? V is equal to IR. So 3 amps flowing through 1 ohm means 3 into 1 is equal to 3 volt is the voltage value. The correct answer here is A, which is 3 volt. Okay. Next question. If a semiconductor switch has a conduction loss of 100 milliwatt, it is given in power, that much is the conduction loss. Okay. For an average current 1 ampere, that is 100 milliwatt for 1 ampere current. This much is the conduction loss. Okay. What is the conduction loss for 2 ampere? We have to find the conduction loss for 2 ampere. Now it is being given that if voltage drop across the device is constant irrespective of the switching current. So irrespective of whatever current may be, the voltage drop across this device or this semiconductor switch is constant. So what this is actually indicating is that while calculating the conduction loss is a power value, right? So while calculating the conduction loss, we don't have to consider voltage because the voltage is, the conduction loss is irrespective of the, or whatever current may be, there is no loss, that is the voltage is irrespective of this loss. Okay, that is the voltage is having a constant value irrespective of the whatever current may be. So there won't be any conduction loss due to the change in voltage. The voltage is considered as a constant. Okay, so here we can calculate power using various equations. P is equal to V into I, P is equal to I square into R or V square by R, right? We can opt any of this equation. But as it is given in the question that the voltage is irrespective of the whatever current may be. So there won't be any conduction loss due to any change in voltage. So while calculating the conduction loss, we don't have to use VI or we don't have to use V square by I because there is no change in that. So we have to use this relation that P is equal to I square into R. Okay. So the conduction loss is calculated using the equation P is equal to I square into R. Right. So here P is equal to I square into R we have to take. Okay. So what is the power or the conduction loss here? It is 100 milliwatt is equal to I square. I is 1 ampere. So 1 ampere square into R. Right. So this is our relation. Now what is R from this equation? It is 100 by milliwatt by ampere square. This is a unit. Okay, now I am using this. I'll tell you. So this is obtained as the resistance or R value. Okay. Now we are going to calculate the new conduction loss for 2 ampere current. So for that we are using the equation I square into R. What is the value of I here? It is 2 ampere square. So 2 square, the unit is ampere square, into R value is 100 milliwatt by, this is a unit, per ampere square. Okay, so this ampere square and ampere square will get cancelled. So it is 2 square into 100 milliwatt. So it is 4 into 100 milliwatt, or it is 400 milliwatt. Okay, so this is the new conduction loss. So why I am using this unit milliwatt per ampere square is that so that I can cancel it later on. So here, in order to calculate the conduction loss for first 1 ampere then 2 ampere, we have to consider that we have to use the relation for calculating the power P is equal to I square into R. Since it is given that the voltage is constant irrespective of the current, we don't have to go for V square by R or VI. Okay, so in order to calculate the conduction loss, we have to use the equation I square R. So from the first relation, calculate the value of R, then substitute it in the next equation. Okay, for that is for calculating the conduction loss due to 2 ampere, substitute the value of R here. Okay, so this simple relationship, you have to just use little intelligence to solve this question. Okay, so we have obtained the value of conduction loss. New conduction loss is 400 milliwatt. Okay, so the correct answer here is C is the correct answer. The next question is this. What is the function of a program counter? So this question you have to answer without even reading the option. What is a program counter? In 8085 or 8051 or any microcontroller, the program counter is the register which stores the address for next instruction to be executed. Very important concept and question. So option is holds the address or address of output of previous execution, no. Holds the address of previous instruction, no. Holds the address of next instruction, correct. None of this also, no, wrong. Okay, so the correct answer is it holds the address of instruction to be executed next. The next question that we are going to discuss is this. What is the guaranteed level of output voltage for a zero state? Okay, so we are going to talk about the TTL here, and we are going to talk about the TTL standard for 0 to 5 volts. So we are considering the TTL voltage of 0 to 5 volt standard, and there are various levels for the TTL logic. So we are going to discuss about the various TTL logic levels or voltage levels. Okay, so here I have marked, see the signals of TTL. There are various output signals, there are various input signals applied to the input. We will be getting certain signals at the output. Okay, so the output can be either high or low, or also the input applied can be either high or low. Now, how to consider that this is high, this is low for input and also output? For that, TTL has marked various standards. So, what is VOL? VOL means it is the voltage, that is a maximum voltage at the output side. Even though it is a maximum voltage, it is considered as a low value. So that is called a VOL. Okay, here I have marked a timeline here for various voltage levels. Starting from the 0, it is a ground, to up to VCC, it is the maximum, or VCC is 5 volt, we are considering it as maximum voltage. So VOL is the maximum output voltage still to be or yet to be considered as a low value. It is called VOL. Next, VIL is the, so if it is a IE, it is at the input side. If it is a O, it is the output signal. Okay. So VIL means it is a input signal. Okay. VIL means it is a maximum value at the input or coming at the input, still to be considered as low signal. Okay. So that is VIL. Now what is VOH? VOH is the minimum signal at the output side, and we are considering this minimum signal to be high. Then VIH is the minimum signal at the input side, even though considering as a, that is minimum signal required to be considered as a high signal. Okay, so that is VOH and VIH. Now I am writing it once again. If it is a V, then it is a O, means it is output. If it is a I, means it is at the input. Okay, then if it is a H, means it is a high signal. If it is a L, means it is a low signal. Right. Now I mark this timeline. So from 0, then VOL, then VIL, VIH and VOH. Okay. Now let us read the question once again and try to answer. What is the guaranteed level of output voltage? So it is VO. Then for a 0 state, 0 means it is a low. Low means it is L. So it is VOL. So this is the concept about the various levels of TTL output voltage or input voltage levels, or generally voltage levels of TTL is VOL, VIL, VOH, VIH. Okay, so I hope this concept is crystal clear to you. Now if you know this concept, how to write this O, how to write this L or H, if you know this, you can answer any such type of questions coming from the voltage levels of TTL. Anyway, the correct answer here is option A, which is VOL. I hope this is very much clear to you. The next questions is this. Which of the memories doesn't get erased when power off? It is a very simple question, right? What is the memory which doesn't get erased when power off? It is ROM, read-only memory. And in that memory, we store all the important contents of the system, files on everything we store in ROM. So it is the ROM which doesn't get erased even if powered off. Okay. Next question. What is the element used in a spike buster? Now, what is a spike buster? Spike buster is a device which is used for protecting the electronic or electrical devices. It is actually used for eliminating the spikes, voltage spikes coming. So, there can be some voltage spikes in between the signal or the electrical signal, right? So, in order to avoid such voltage spikes or eliminate such voltage spikes, we use a spike buster, and in that spike buster we use a metal oxide varistor or MOV we use. Now this metal oxide varistor is able to handle high amount of power and high amount of current, and at a certain voltage rating it is able to handle high current spikes and high that is voltage spikes. It can be, that is voltage spikes, it eliminates. Okay, so anyway, the device used is specifically metal oxide varistor or MOV is the device or the element used in a spike buster. Now the function of a spike buster is to eliminate voltage spikes. Next question. 1 unit of electrical energy is dash. 1 watt hour, B 1 kilowatt hour, C 1 kilojoules, D 1 horsepower. So if you have talked about this 1 unit of current or 1 unit of electrical energy, it is 1 kilowatt hour. Okay, so if you see the units in your meter, you can see these units. 1 kilowatt hour is equal to 1 unit of electrical energy. Okay, so the correct answer here is option B. Convert 1001, 1000, 1011, 1010, 1100, 0101 to hex. Now, for all such questions, in order to convert any BCD number or binary number to hex, I have drawn this chart for you. Okay, so here all the binary numbers are here till 10, up after 10, 11, 12, 13, 14, 15 is here. So, binary its corresponding decimal, its corresponding hex value. That is, the hex value corresponding to these binary numbers are here. So for 0, it is 0, 0, 0, 0, it is 0, hex value is 0. 1, it is 0, 0, 0, 1, it is 1. Then hex value is 1. And also for 0, 0, 1, 0, it is 2, 0, 0, 1, 1, it is 3, 0, 1, 1, 0, it is 4, 0, 1, 0, 1, it is 5, 0, 1, 1, 0, 6, 0, 1, 1, 1, it is 7. Then after 7, 1, 0, 1, 1, 0, 0, 0, it is 8, 1, 0, 0, 1, it is 9, 1, 0, 1, 0, it is 10, so then 11, 1, 0, 1, 1, it is 11, 1, 1, 0, 0, it is 12, 1, 1, 0, 1 is 30, 1, 1, 1, 0 is 40, and all ones 1, 1, 1, 1 is 50. Now up to 9, the decimal value is equal to hex value, and after 9, that is for 10 it is A, for 11 it is B, for 12 it is C, then for 13 it is D, 14 it is E, and for 15 it is F. So if you know this binary, decimal and hex values, you can answer any questions coming on this area. Okay, now let us see the question. Okay, don't just read out the question once again. We'll write from this chart. 1001 means it is 9, right? So it is 9. Then 1008, 8. 1011 it is B. 1011 is B. Then 1010 is A. Then 1100 is C. Then 0101 is 5, right? Yeah. So the answer is 9, 8B, AC5. So the correct answer here is option B. So please note this chart down. Anyway, this is very, very useful for you for any competitive examinations of electronics. I'm sure that at least one question will come from this area, or even if it is not coming from that area, if you study this chart, it is very, very useful for you for your future also. So please note this chart down in any of your important areas or notebooks, so that it won't get, that is, you won't forget that you have written it somewhere. Okay, so please write this down. So after 10, I have written it here. Okay, since there is no space in the board, I have written it here. Okay, so let us see the next question. Next question is this: which of the following is an application of pin diode? Pin means it is having a P-type semiconductor, then an intrinsic semiconductor and an N-type semiconductor. So an intrinsic semiconductor is stuffed in between a P and N. So what will happen? During the forward bias condition, all the carriers are rushing to the intrinsic semiconductor. So they are used for high frequency applications. Okay. Now there are various other applications of pin diode also. Let us read out the options. A, high voltage rectifier. B, variable resistor. C, RF switch. It is one of the very important application of a pin diode, RF switch, radio frequency switch. As I said, it is used for high frequency applications. It is used as a RF switch also. D, all of this. The correct answer here is all of this. The PIN diode is used for all of these applications. The correct answer here is option D, which is all of this. Next question. A receiver consists of an envelope detector and comparator. What type of modulation it is? So this is a digital. I have skipped this term, sorry. What type of digital modulation it is? A, FSK, B, PSK, C, ASK bar OOK, D, none of this. So what is being asked? So they are asking about the digital modulation. Digital modulation means we are modulating digital data for in order to represent our carrier signal or modulating signal. Okay, here in case of a frequency shift key, the frequency, as per the frequency of your message signal, the digital data is modulated. B, PSK means phase shift keying. So if you are seeing this term called keying, it is a digital modulation. C, ASK means amplitude shift keying. Bar OOK means on-off shift keying or on-off keying. D, none of this. So in the question they are saying that at the receiver side there is an envelope detector and a comparator. The receiver consists of an envelope detector. Envelope detector is always used for detecting of amplitude variations. In most of the cases, this envelope detector is used for detecting your amplitude variation or the amplitude or the envelope of your signal. So this can be used for amplitude shift keying, and also for on-off shift keying means it is a very basic type of or a variation of amplitude shift keying, where when the signal is present, we send a digital data. When the signal is not present, there is no digital data. Such type of keying is called on-off shift keying. Okay, so that is on-off shift keying and amplitude shift keying. Amplitude shift keying means as per the amplitude of your carrier or the modulating signal, your digital data is modified. So that is ASK. The correct answer here is ASK bar OOK. Since the receiver is having an envelope detector and a comparator, it can be for on-off shift keying or amplitude shift key. Okay, so the correct answer is option C. Next, a 12-bit clock divider is used to divide 50 megahertz clock. What is the output frequency? Since the duty cycle or anything is not given in the question, and we are going to divide a 50 megahertz clock by 12-bit clock divider. So 50 by 12, which is 4.16 megahertz will be your clock frequency. Okay, so the correct answer here is option D, which is 4.16 megahertz. What happens inside an optocoupler? So what is actually an optocoupler? Optocoupler means it's a coupler used for coupling or connecting or having a connection between two isolated circuits. Consider this is an isolated circuit. This is another isolated circuit. So in order to have a connection between this, we use light as a medium and we use a optical transmitter and a receiver at this side. So consider this is a transistor. Okay. So light will be sent from this circuit to another circuit. So in order to have a connection between these two circuits, which is isolated otherwise, we use light as a medium. So how to actually do this? We have to convert the electrical energy to light, then or optical energy, then converting back the optical energy to electrical energy. Only then the connection is happening, right? So in order to have an optical coupling, first we have to convert electrical energy to optical energy, then transfer it as in the medium of optical form. Then at the receiver side, convert optical energy back to electrical energy and have a connection between these two isolated circuits. So what happens inside an optocoupler? Optical to electrical conversion? No. Optical to optical conversion? No. Electrical to optical conversion followed by optical to electrical. The correct answer here is option C is the correct answer. D, none of this also no. Correct answer is C. What is the output of circuit? So we are going to give a square wave of 0 to 5 volt. That is minimum 0 and maximum of 5 volt as we to this common emitter connection, and the output is taken from the collector side. Okay, so this actually acts as an inverter circuit. So when we are giving a 0 to 5 volt, the output will be getting inverted. Okay, that is 0 to 5 volt in a inverting configuration. Okay, so the correct answer here is option C, which is toggles between, option D, which is toggles between 0 to 5 volt inverted. So this configuration of the BJT, that is applying input to that is a square wave or a high-low signal, is applied to the base region as input and taking output from the collector side is acting as an inverter circuit. And if this collector circuit is being connected to VCC and you are taking the output from the emitter side, consider that the emitter side is acting as the output side. Input is being applied to the base. This is RB, this is RC. So here you are applying the input to the base and the output is taken from the collector. And your output is taken from the emitter, input is applied to the base and the collector side is connected to the VCC. Okay, so this acts as a voltage follower. So these are the two configurations of your BJT. This configuration acts as a inverter when we are applying a square wave, and also this acts as a voltage follower. So these are the two configurations. So this configuration acts as an inverter. So your output, if you are applying a 0 then 5 volt square wave, 0 to 5 volt square wave, if you are applying, you will get a toggling waveform in the inverting configuration That is, it toggles between 0 to 5 volt at the output. So the correct answer is toggles between 0 to 5 volt inverting. Correct answer is option D is the correct answer. Which of the following converters are isolated? So what is actually a converter? So converters are generally used to either increase or decrease the value of your voltage. Voltage level for increasing or decreasing, generally converters are used, DC to DC converters. Okay, so out of these options, which converters is isolated? Now what is called isolating of converter? So in isolated type of converters, the input side is isolated from the output side, both electrically and physically. So in this type of isolated converters, there is no current flow from the input side to the output side. So that is called isolation. And this isolation is made possible with the help of using transformers. So you should be able to understand this concept. So in order to have isolation, we use transformers. And out of these are various type of converters. The forward converter is a isolated converter, and this converter is using a transformer for having isolation. Other converters are non-isolated converters. That is, there is a coupling or connection between the input and the output circuit. Okay. So the correct answer here is A, which is forward converter. So I hope the concept of isolation and converters is clear. Next question. In a CRO, output frequency of time-based signal is dash. A, fixed signal. B, random signal. C, proportional to voltage. D, an adjustable signal. So if you have at least used once CRO in your lifetime, you should be knowing this. We know that your output frequency can be adjusted. In order to have a signal to be more clarified, we can actually reduce the frequency or increase the frequency, and we can actually see the signal. So your output frequency is an adjustable signal. Okay. It is not proportional to voltage. It is not a fixed signal. It is not a random signal also. It is an adjustable signal. So this is actually a practical type of question. Okay. Since it is the examination was supposed to have technical assistant, you should have a practical knowledge also. Okay. Next question. Input-output relationship of boost converter. So this is also a question related to converters. So this boost converter means it is also a DC to DC converter, and this DC converter is used for increasing your output voltage. In order to increase output voltage, we use a boost converter. So the term boost also is relating to that. So boosting means for boosting your voltage. Output voltage is greater. Okay, so what is the relationship here? The input-output relationship is this. V out is equal to, I'll write it here. V out is equal to V in by 1 minus D is the relationship. Where V out is your output signal, V in is the input signal. Then 1 minus D, where D is the duty cycle. So in this, I'll draw the circuit for this boost converter. I'll draw it here. Okay. So I'm going to draw the diagram of a boost converter now. There is a source. V in is a voltage, there's an inductor, there's a switch here. This switch is actually either BJT or MOSFET can be used as this switch. Then there is a diode, there is a load out where you will get your output. Now the relationship is V out is equal to V in by 1 minus D, right? So V out is equal to V in by 1 minus D. Now what is D? D is the duty cycle of your switching signal. So there is a switch here, and this transistor is acting as a switch. Okay, and there is a switching signal, and D is the duty cycle of your switching signal. Okay, so this is the input-output relationship. V out is equal to V in by 1 minus D. Correct answer here is option A, which is V out equal to V in by 1 minus D. Okay, so these are the questions which I have included in this video. I have tried to increase the number of questions in this solution video. So I hope that this video was useful for your preparation. I have tried to introduce new concept along with each questions, and I have also tried to give maximum information regarding each question. So if that was useful, please do give it a thumbs up and share this video with maximum of friends. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.